Good morning everyone. So in this class I am going to explain differential geometry. Differential geometry ನಲ್ಲಿ ನಿಮಗೆ ಫಸ್ಟ್ ಚಾಪ್ಟರ್ ನ ಸ್ಟಾರ್ಟ್ ಮಾಡಿದ್ದೆ. ಅದರ ಮೇಲ್ಗಡೆನೂ ಕೂಡ ನಿಮಗೆ ಒಂದಷ್ಟು ಇಂಟರ್ನಲ್ಸ್ ಕೂಡ ಬರೆದಿದ್ರಿ. ಅದರಲ್ಲಿ ಇನ್ನೊಂದು ಕಾನ್ಸೆಪ್ಟ್ ರೀಪ್ಯಾರಾಮೀಟರೈಸೇಷನ್ ಅನ್ನೋ ಒಂದು ಕಾನ್ಸೆಪ್ಟ್ ನ ಮಾಡಿರಲಿಲ್ಲ. ಓಕೆನಾ? ಸೊ ಈ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ನಾನು ರೀಪ್ಯಾರಾಮೀಟರೈಸೇಷನ್ ಮುಗಿಸಿದ್ರೆ ನಿಮ್ಗೆ ಅದ್ರ ಮೇಲ್ಗಡೆ ಒಂದೆರಡು ಥಿಯರಮ್ಸ್ ಮತ್ತೆ ಪ್ರಾಬ್ಲಮ್ಸ್ ಇದೆ. ಅದಷ್ಟು ಮುಗಿದ್ರೆ ನಿಮ್ದು ಫಸ್ಟ್ ಚಾಪ್ಟರ್ ಕಂಪ್ಲೀಟ್ ಆಗುತ್ತೆ. ಓಕೆನಾ? ಸೊ ಅದಕ್ಕೂ ಮುಂಚೆ ನೀವು ಡಿಜಿನ ಬರ್ತಿರ್ತೀರಾ, ಯಾರು ಓದಿರೋದಿಲ್ಲ, ಗೊತ್ತಿದೆ ಅದು. ಸೊ ಫಸ್ಟು ನಾನೇನು ಚಾಪ್ಟ್ರಲ್ಲಿ ಬೇಸಿಕ್ಸ್ ಡೆಫಿನೇಷನ್ಸ್ ಬರ್ತಿದ್ದೀನಿ, ಪ್ಯಾರಾಮೀಟರೈಸೇಷನ್ ಬಗ್ಗೆ, ಆರ್ಕ್ ಲೆಂತ್ ಆಗಿರ್ಬೋದು, ಆರ್ಕ್ ಲೆಂತ್ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡೋದಾಗಿರ್ಬೋದು, ಅದನ್ನ ತೆಗೆದು ಒಂದ್ಸಲ ಕುತ್ಕೊಂಡು ಓದ್ಕೊಳ್ಳಿ. ಓಕೆ, ಅದಾದಮೇಲೆ ನೆಕ್ಸ್ಟ್ ನಿಮ್ಗೆ ಇದ್ರದ ಕಂಟಿನ್ಯೂಷನ್ ಸಿಗುತ್ತೆ. ಓಕೆ, ಸೊ ನಾವು ಹಿಯರ್ ವಿ ಸ್ಟಾರ್ಟ್ ವಿತ್ ರೀಪ್ಯಾರಾಮೀಟರೈಸೇಷನ್ ಡೆಫಿನೇಷನ್. ಲುಕ್ ಹಿಯರ್, let alpha be a curve. Alpha is a function from I to R power n be a curve, and if gamma is a function from J to I is a differentiable function on an open interval J, then the composite function beta is equals to alpha of gamma. So this function is this function from J to R power n is a curve, is called a reparameterization of alpha by gamma. Okay, so this curve is a reparameterization of alpha by gamma. Again, so even the definition ಇನ್ನೊಂದು ರೀತಿ ಡಿಫೈನ್ ಮಾಡಬಹುದು. ಯಾವ ರೀತಿ ಅಂತ ಹೇಳಿದ್ರೆ, a parameterized curve beta is a reparameterization curve alpha if there is a smooth bijective map such that the inverse map gamma inverse is also a smooth. Okay, then this function can be represented as beta of s is equals to alpha of gamma of s here for all t belongs to I and s belongs to j. So this is the definition of reparameterization. Okay, so this is the diagrammatic representation of a reparameterization. Now look here, since gamma is a smooth inverse, then alpha is also a reparameterization of beta that can be represented as beta of gamma inverse of t, which is equals to alpha of gamma inverse of t. This can be represented as alpha of t for all t belongs to interval I. Okay, so ಇದು ನೆನಪಲ್ಲಿ ಇರಬೇಕು ನಿಮಗೆ. Okay, beta of gamma inverse of t can be represented as alpha of t. Okay, next we move on to the another definition, that is curvature. So curvature ಅಂದ್ರೆ ನಿಮ್ಗೆ ಆಲ್ರೆಡಿ ಗೊತ್ತಿದೆ. Curvature means it is the measure of the extent to which a curve is not contained in a straight line. Okay, that is known as curvature. So here the straight line having the zero curvature. So straight line ಗೆ ನಿಮಗೆ curvature ಏನಿರುತ್ತೆ, zero ಇರುತ್ತೆ. So similarly now we have to define a curvature of parameterization S. Okay, look here, let alpha be a unit speed curve with the parameterization S, then its curvature can be represented as k of s at the point alpha of s. Now we defined as k of s is equals to curvature can be represented as k of s, that is equals to norm of alpha double dash of s. K of s ನ ಯಾವ ರೀತಿ ಡಿಫೈನ್ ಮಾಡ್ತೀವಿ, k of s means curvature is equals to norm of alpha double dash of s. Okay, this is the curvature definition. ಸೊ ಈ ಕರ್ವೇಚರ್ ಡೆಫಿನೇಷನ್ ನಾವು ನೆಕ್ಸ್ಟ್ ಥಿಯರಮ್ ಅಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ಕೊಳ್ತಾ ಹೋಗ್ತೀವಿ. ಓಕೆ, ನಾವು ನೆಕ್ಸ್ಟ್ ವಿ ಹ್ಯಾವ್ ಟು ಪ್ರೂವ್ ಅನದರ್ ಥಿಯರಮ್, ದಟ್ ಈಸ್, ಲುಕ್ ಹಿಯರ್, ದ ಥಿಯರಮ್ ಈಸ್, let alpha of t be a regular curve in R power n, then we have to prove that the curvature is equals to norm of alpha double dash cross alpha dash over norm of alpha dash whole cube. Okay, so here cross product represents, cross indicates the vector cross product. Okay, we call this as equation number 1. Now look here we have to prove the curvature of the parameterized curve alpha of t. Okay, now let's start to prove this theorem. So look here, let me consider beta of s be a unit speed reparameterization of alpha of t, then by using the chain rule. Now we have to know that beta of s is equals to alpha of t. Previous ಅಲ್ಲಿ ಬರ್ಸಿದ್ದೀನಿ. Okay, note ಅಲ್ಲಿ ಇದೆ ನೋಡಿ, beta of s is equals to alpha of t. Now we have to differentiate beta with respect to t. Okay, so we get beta dash of s is also a function. Again we differentiate this one with respect to t, we get ds by dt, which is equals to differentiation of alpha of t, we get alpha dash of t. Okay, now look here, this can be represented as beta is equals to alpha dash divided by this one we cross multiply to this one, we get alpha dash divided by ds by dt. Okay, so now we know that curvature can be represented as k is equals to norm of alpha dash of s. Here we consider beta as a reparameterization, unit speed reparameterization. So curvature can be represented norm of beta double dash, which is equals to differentiation of this one, d by dt of this function alpha dash divided by